Welcome back. In the last video, we learned about heap memory and stack memory, and how value types and reference types are stored in each. In this video, we'll write some code to explore different variable types in action. Open the C# project file we created in the My First Program module. Copy its contents. Then create a new file named playingwithvariables.csproj. Make sure you store the file in some different location than the previous file. Save it, and then paste the copied content into it. I recommend writing the .csproj file yourself to better understand its structure. Now create the .cs file as we created in our My First Program in the same location as playingwithvariables.csproj file, and write the code shown on your screen. Make sure you type this code, do not copy-paste. Once you are done writing the code, from command prompt execute the .NET run command and make sure the program is working and printing hello world on screen. Now, I am going to create an int variable named employee ID. Usually in real-world applications, integer variables are used for counting IDs, storing employee numbers, small calculations, etc. I am now initializing employee ID to the value 20. Now let's print this variable with console.writeLine method. Here I am getting some error while running the program. The C# compiler is complaining there is something wrong at line number 11 and column 41. Here I missed to add the plus sign to concat the string with the integer. I encourage you all to try solving compiler errors on your own. Don't worry if it takes time. Making such mistakes is a normal part of the early stages of your programming journey. If you're a beginner, it's important to make an effort to fix these errors yourself. Use Google or ChatGPT by copying the code along with the error message. The more errors you solve on your own, the better you'll become. Let's talk about integer values for a moment. Int in C# is an alias for system.int32, which means you can write int32 instead of int as well. The size of an int is 4 bytes. Which means 4 times 8 bits is equal to 32 bits. A bit can be either a 0 or a 1. So, the maximum and minimum values that an int can store are shown on your screen. That's because it uses 32 bits. 1 bit is used for the sign positive or negative. The remaining 31 bits are used to store the value. So, if we ignore the 1 sign bit and calculate 2 raised to the power 31, we get the same maximum value we saw earlier. Let's try this in C# code. I am assigning the maximum value we just discussed to the employee ID variable. Let's see what we get when we run the program. We can see the value is printed on the screen. Now, let's increase that number by just 1. As you can see, the C# compiler is throwing an error because we have exceeded the maximum limit of int. There are predefined ways where we can know what is the size of an int and what is the maximum and minimum value of an integer. To do that, we can take help of C# size of operator and max value and min value properties. We will learn about the operators and properties later in the course. For now, just know that the size of operator gives you the size of a data type in bytes, while min value and max value properties gives you what maximum and minimum value a variable can hold. Please follow the video and type the code by hand as shown on the screen. You may pause the video at any point to check whether what you've written is correct. Now when I run this code, I can see the size of the int is printed as 4, which is in bytes, and also the min and max values of int. Now take a moment and try writing the same code for other data types shown on the screen and observe the values. Also, repeat this exercise for all available value type variables. Next, we will look at some commonly used data types and their typical usage in real-world applications. One, integer is used for storing whole numbers like employee IDs, item counts, or age. 2. Float, floating point number, is used for measuring approximate values like temperature, speed, or rating when precision isn't critical. 3. Double is used for more precise values like scientific measurements, distances, or coordinates. 4. Decimal, high precision number, is ideal for financial and monetary calculations where accuracy is crucial. 5. Character is used for storing single characters like grades, initials, or status codes. 6. Boolean is used for representing true or false conditions like feature toggles, switches, or user login status. 7. Byte is useful for image pixel values, file sizes, or low-level operations like networking. 8. Short is useful for storing smaller ranges of values, like port numbers or small counters. 9. Long is useful for representing large numbers, like population, bank account numbers, or timestamps. 10. String is used for storing names, addresses, file paths, or any textual data. 11. Object is used when the exact data type is unknown at compile time. 12. Dynamic is useful in scenarios where the type might change or is unknown at compile time, like working with external data. 13. Enum, useful for representing a fixed set of named constants like order statuses or user roles. And that's a wrap. Catch you in the next one. Stay curious, stay coding.